Hello all, thank you for joining. This presentation is about Devops for Databases, and today's agenda is for Devops. What is it for databases? Devops models, and I will also be showing some sample CI/CD processes, and I will also show some DevOps tools that every DBA must know. And where does DBA fit in a DevOps environment? And we're also discussing about the database provisioning as a part 1, and the part 2 we are going to see how database changes can be managed in a DevOps environment, and we will see some differences. Let's see. So what is DevOps? DevOps is basically a regular, rapid, reliable, and controlled delivery of working software systems into the production. Continuous delivery of it. A combination of a configuration management, release management, and operations. It's a culture or philosophy rather than a technology, and automation is a key for success. In a DevOps environment, majority of the work is done via automation and with the help of tools. So by combination of certain tools and processes, we can do the DevOps. So DevOps continuous model will work like this. From the plan to operate, it consists of different categories: plan, code, build, test, release, deploy, and operate. So continuous integration phase will be from the plan, code, and build, where the continuous delivery comes with plan, code, build, test, and release. Once it is released, it is ready for the deployment to the production. Once it is deployed, it's ready for the operation. So this is all included in one particular piece of sequence where developer can release their code, build it, test it, release and deploy automatically with help of some tools. Continuous of what? So with agile practices in place, very frequent releases in place, so configuration management and testing along with continuous integration delivers you a constant development piece of code with the source controlled and version controlled in place. We do all our code changes into the integrated environment with the help of master and trunk baseline our code. Second thing is, in the continuous delivery of a code to environment, once the developer feels the code is ready to ship. The idea behind the continuous delivery is that you constantly delivering a code to your user base, whether it be a QA or directly to the customers review and inspection along with the testing code. The basis of continuous delivery is to have small batches of continually fed to the next step. That means a small changes, releases can be taken to systems, to one system to another system seamlessly, flawlessly with the help of automation. So once the continuous delivery has been done, it is ready to deploy to the production as soon as it is ready. So the key feature of continuous development is basically with the help of continuous integration and continuous delivery. So this is all what about the continuous. What all this continuous is. This is how it looks like. If you look at developers work in their local environment and push their code to the branches, to the developer branch in the source control, once it is ready, whenever there is a code commit happens, it passes to a CI server called integration server, where the integration environment is running, and once it is successful here, it can be deployed to UAT or staging or test environments, and then in the production CI servers, they can push that into a main pipeline and then deploy to the production. So this is all the seamless process with help of all the automations and the tools. And if anything got failed, it will be revert back to the previous versions of it. So automation is everything, source control everything, strict adherent to the process will help you to achieve this DevOps model in any organization. But so in broader perspective, if you have more releases, you are doing a lot of configuration changes by your system admins, like changing URLs, configuring servers, configuring applications, load balancers, etc., in configuration systems for web app and system admin changes. And also the release management, some new releases from the developers happens frequently. There the DevOps model can fit into there. But where does the DBA sit here? So that answers the book from this slide. What your role is basically in your organization. Is it a configuration management or your release management? Are you building databases, infrastructure, configuring your databases? Just deploy the database changes irrespective of maintaining them. So if you are a database developer, like working with your app teams, deploy the database objects, design the tables, etc., manage the database version migration. So this comes under your portfolio. So we need to understand basically both of these and try to understand how we can deploy the databases or manage the database in a DevOps environment. So it depends on your role as well. If you are predominantly working on this, these are the things that you need to do. If you're predominantly working on this, these are the things that you may need to do. So what we need to maintain. If I'm managing a core DBA, like doing a core activities of the database, managing my databases, creating a databases, refresh my databases, what I need to do is basically the same principles we can apply, a bunch of scripts, integrate that, deploy to the next servers, test that, copy artifacts to a separate server, and then build. So similarly, whatever the databases changes you will have, you may have the source control, automated, source control your data, etc. in a bunch of scripts, integrate that and manage, deploy, test, copying your artifacts, and then build your refresh databases. So this is how it works. So what all basically we know is, we need to know is the tools. So if you look at the plan ways, these are some of the tools that you may need: version control tools and the planning tools like Jira, or your any ITL tool practice, any kind of tools that you can have: Jira, Confluence, Git for version controls. And to want to build some servers, you can have Maven and Gradle and all. If you want to test, you can use a JUnit or dbdiff for the databases. You can use those things, and combination of your integration systems like Jenkins, Bamboo, and other things. And you can deploy them using some deploy tools called Puppet or Chef or SaltStack and operate them with your monitoring tools like New Relic, Sensei, and then Nagios or Asinga, any other tool. So ideally, you need to know about these open. Some of them are open source, some of them are commercial tools, but we may need to know these tools as well, apart from our database skills. So this is how our pipeline model looks like. As you see here, we have an int environment, we have a test environment, we have pre-OIT environment, we have prod environment. When there is a change happen in any of this particular component, as you see, we have a CloudFormation as a component, broker, CloudFormation again, and then LDAP services running, live person chat is running, mail running, Nginx servers, app servers, PeopleSoft app servers, batch servers, web servers, and also we have a Solar box, we have a web application running. So we have a different components of each of these things. We maintain these piece of codes in the source control as their cookbooks, and then whatever changes happens in the cookbook, it will be automatically pushed to the int environment, and test happens. Once it is done, it can go to the next environment and the next, and then deploy to the production. This is a sample pipeline configuration. So what we all here managing is basically the infrastructure as a code, like our CloudFormation. All of our servers, everything will be built using CloudFormation scripts. Once that is done, we have a middleware components and the application components. We also have some tests happens. Once this all been done, we do some small basic tests whether we are able to access, the servers are created properly, the app servers have configured properly, everything. We do some small smoke tests on it, and when you're done, we integrate the components. This is how it looks like. The developers push their commit changes to the any of the web code, monitoring change or a configuration change by sysadmins or the developers. The version control Git bucket will take that, and then Jenkins server or pull request job constantly look into the source code system and then take that change and start deploying into the int environment, integration environment. So for the CloudFormation or for the LDAP or for the web, and then it goes to, once it's successful there, it goes to TST9 automatically, and then apply the same piece of code there. And then once it is done, it will apply the same code in the pre-OIT, and it is ready to go to production. So this is how all done through an automation with help of a lot of tools that I've told, like Git bucket, Jenkins server, the wrapper scripts, your Chef servers or the Puppet to deploy these changes, to deploy those cookbooks or changes to this particular piece of components. Now we want to keep the databases here in this pipeline model. How we can do that? So if we are telling about a database deployments, it can be two. Either we're asking database provisioning, configuration or refreshing, or we are looking for a database changes or a migrations. So database provisioning or a configuration can be a parameter change, a new database creation, a new refresh, or a new table space, or something else. When it comes to the database changes, it can be a new structure has been modified, a new object has been created, a new procedural code has been introduced, something like this. This is all database changes. This is all database configuration changes. So how are you going to manage it? So how are you going to keep that? So let's look at that. Devops for databases, configuring, creating and managing databases. What we can do is take a case of one case, create a new database. How do you do it? Most of us have a way of automating our database creation in a silent mode or in running some scripts, extracting an RPM package and something like that, right? So most of us having that way. When we really have those automation scripts ready, just make sure your script is more parameterized so that we can feed whatever environment we want. Build a wrapper script to call the scripts and install the database type in the target server. Ensure our script covers most of it, right from creating database to add monitoring tools. This is the key piece of it. Majority of us, what we will do, we'll just create the database and ask scheduling monitoring team or the scheduling tool to deploy the scripts or start monitoring the server. But in a DevOps environment, our script has to manage creating database from right away, from adding that monitoring tools as well. So we need to know some monitoring tools, how the monitoring tool work in our environment and everything. So let's look at it. So this is our sample Jenkins project which creates our databases. Our DBA actually what they does is whenever we ask a new fresh database, they will select what the version they want, what type of database want, the database name, port number, and what is the host name, target server they want. They can do that. Once it is done, Jenkins go to our Bitbucket and then take our two things called a bunch of our automation scripts and look at the software repository, copy them to a target server, and then start deploying my database. That's as simple as such. There's no rocket science involved here. It just does simple things. Create my database, add maintenance scripts, add database to my scheduling tools like for backups and everything, add database to monitoring tools. That's the simple piece of thing it do for whatever the database I ask. It's just as simple as such. You just need to run. Either you can run in shell scripts, you can run Python, you can do anything. Just a new database to be created in a automated way. So once it is done, it can be in cloud also. That's not a problem. It's just when you are in cloud, you just may ask your AWS CLIs or cloud formations or templates or Azure resource templates kind of thing. You just need to call them from your integration server, and then it start creating the database in your cloud as well. So it's all basically either a shell script or a command line interface or anything. You just call it from a wrapper. So refresh the database from a silo. I mean, a silo database that need to be refreshed from production, test, or any other server. Again, what it means, you are doing refresh every day in and out. You just need to maintain that script, parameterize it, and automate it. That's what all you need to do. You start with database one, like Oracle. You may end up with different databases, but you may already have all the scripts. You just make it ready, start working on them, and then put that into a Git repository. So we have another project called database refresh. We'll say what is our source database, target database. We'll give the database names. It looks our inventory and then takes the database host name and then go to our Jenkins server. So Bitbucket, take the bunch of scripts, take a backup of my database, copy those backups to the target server, and then override the target database. So what it has to do is just log into that particular source server and then copy there. So your integration server or your integration machine should have all the database clients installed here. That's the one of the important piece of thing that we can do. There are a mechanism. You may already have sorted out everything. You just put all the, so we have MySQL, Vertica, Postgres, Oracle, and MongoDB also as a part of our database stack. What we just done is basically we installed all the clients in one of the integration servers and start calling the scripts and do the backups and those stuff. But ideally, if it is a very big databases, copying backups are those cumbersome. But ideally, in a DevOps environment, if you're dealing with a small set of databases, this is one way of doing it, refresh the database easily. Now, there is a third case where we want to create the database automatically along with the stack. What is meant by stack here is basically it contains of web, batch, database tools. This is fully automated way. Generally happen in cloud or hybrid environments where your servers must be provisioned automatically, software must be installed automatically, configuration must be done automatically. Having said that, you need to have an infrastructure as a code maintained in your source control. This is the first and primitive thing that we need to do. But from database perspective, if you already met case 1 and case 2, that is creating your database, refreshing your database, it's just need to attach to this. That's it. What type of database, what type of database you want to create, whether you want to create with stack or silo, we just need to mention that, and our database scripts will be calling from that sequence. So this is how we have used our automation scripts to call from the Jenkins server in simple way. Now that's how you can provision your databases using your own automated scripts through a Jenkins server or any other orchestration tools. So the first part basically concentrate on how you're going to use your existing scripts in a Jenkins environment or in any integration environment to automate your provisioning, database provisioning steps, either refresh or backups or any other things. So once you solve the database deployments, the second part of the story is basically managing your database deployments, which is very hard to do or very complex to do. So majority of the people says that we do have a lot of problems in database deployments, that is database migrations or changes. So why databases are so hard? The reason is that database have a very unique properties. The thing is, database is not a bunch of SQL scripts like your application configuration files or something like that. It's not that. It contains your complex piece of procedures, table structures, indexes, triggers, functions, etc. And also dependencies between the objects. Database is a central resource. It is accessed by multiple resources like app servers, web servers, and everything. Deploying database changes is not as simple as copying your config.xml and then change it. Database deployment is a transformation of one from version A to version B, and keeping the business data transforming into a new structure. Database code exists in any database and can modify directly in environment. This is unlike other components where everything starts from a clean workspace in the build server. This point we'll see that later. So some comments like it is very difficult, who changed that. Some comments also say, some of the application team says that our latest version does not have an updated script of database, hence the version, the change and the deployment got failed. So we heard all this, we heard all these issues. So we need some sort of tool, version control tools or data control tools in order to deploy or changes to the database seamless. Generally, application development's life cycle starts from development and ends with production like this. So they develop and then test and then put it in production. Wherein the databases, what they ask basically, they will ask refresh the database from production. So that's the version X will be deployed and then go to development. So it's against to the cycle. Basically, it's against to the cycle. We refresh the database from production and then developers start building on that. It's a one way of doing it. So why it is so hard? Again, even though we build the database from scratch and refactor the database, for big database, it will delay the whole deployment of new stack. That means if you are building it from a clean vanilla database and start applying all your scripts, still if for the big databases it will be very cumbersome. Furthermore, if you use refactoring method for building new databases, how you version control your data. So this is very key thing. So we need to have a clear defined strategy for refreshing and refactoring the databases. So these are the main common challenges that databases are hard to implement in a DevOps cycle. Version control is one thing. Against to the flow. Complexity as such, it's a shared resource. Version controlling your data because of the volume because of the transactional data. But when you want to do the transactional data, really ask your teams, do they need the transactional data or just a configuration data is fine or not? So that way we can segregate and we easily can manipulate that. So when we say version control everything, the version control everything is basically everything. We can maintain all, like your installation scripts, migration scripts, performance scripts, reference data, stored procedures, triggers, etc., etc. But think about this: how you manage these kind of databases, PeopleSoft, SAP, and eBusiness Suite databases, enterprise databases, which having hundreds and thousands of tables like this. If you see here, I have 17,000 views, 27,000 indexes, 23,000 tables, which is in a PeopleSoft environment. How are you going to version control it? Even if you do the reverse engineering and thing, how are you going to put the data there? So we need to very be careful in implementing the databases in a DevOps environment. Unless until you're a custom database, not PeopleSoft, SAP, or EBS, you can actually get them into the version control. Now, how to version control the data? Versioning of data or mapping of database to a right version of application. Say as an example, if I have app version 1, which is having 10 tables, if I say database version which is having the same structures of it, if I say app version 2 and it having database version 1, which is not that, app has already changed and it is actually looking for 11 tables, not 10 tables. Where is the 11th table? Who is going to create that? Where are you going to keep the code? How about in data? So this all comes. But before to that, do we really need to bother about the transaction data? No. But reference data like configuration data, everything should be there. Because if this data will be there, that would be easy for us to manage it. So, so what we did basically is whenever the database is changed, is deployed, we took a backup of database, tag it with the database version, either armand tags or project tags or anything, update the DB file version with the latest database version of backup in the source control, update the master file version which contains both of these, app version 1 and database version 1. So whenever we deploy app, we deploy the database 1.0, which also contains the backup of it and restoration scripts and everything. So this way we managed our database backups, our database refreshes, along with the app refreshes, app upgrades or app releases. So general principles for database deployments is must have requirements for database changes in DevOps environments is ensure all database code is covered, that is structural code, reference content, grants and everything. Ensure DB version control repository act as a single source of truth rather than the database itself. Your version control is the source of truth, like it have a base version of your schema scripts and the next version and the next version and the next version. Ensure the deployment script is being aware of environment state when the script is executing. That means if someone is deploying, there should be a lock mechanism or something which it actually has to manage all this. Ensure that the script handle consistency between merges them. Generate a deployment script for only relevant changes. Ensure the deployment script is aware of the database dependencies. Ensure source control of the data is required. So if the data is required, you must take a backup, tag it. So managing database migration generally happens managing your SQL scripts in a source control or through a change logs or a comparison tools available in the market. But most of them does not cover all aspects of your migration scripts. You may end up with multiple tools or through the migrations. Hence, the database deployments are always left behind from the CI/CD pipelines. Guidelines for selection of your tools. Support for multiple databases for multiple schemas. Support for multiple technologies, like all databases should be covered. Support for rollback changes just in case any defects happens. It need to roll back automatically. Right? Support for rollback changes in case of defects. support for version control rather than the depending on the source control system. Support for version controlling database code, that is procedural code. Support for baselining version and compare scripts. Reference data ability or the backup scripts ability. So these are all the guidelines that you have. In a tabular format, I kept the same thing. So these are some of the tools like Liquibase, MyBatis, Flyway, dbdeploy, dbmaestro, Redgate, Datical, Jailer, Diffgate, dbunit, dbfed, data anonymization tools available in the market as open source. Some of them are commercial, something. So I just try to compare the popularity of these tools from the commercial tools versus the open source tools. So I have Flyway and the Liquibase and MyBatis, and in the open source have more popularity than any other tools I have. So, but popularity does not give me the end-to-end requirement, but at least what organizations, what are the other organizations are using the database migration tools, we can get some sort of interest from the Google as well. So this is how database migration standard approach should be. So developers have local databases in them, and then they can deploy the scripts and then put them into source control repository. Our CI/CD servers can take that and apply that changes one after another in the pipeline. So this is basically 1.5 script, 1.6 scripts, but the production is in 1.4 deployed. Each developer should have their own databases. Whenever developer wants, he can pull the latest database by removing his local copy. All developers should commit to source control, ensure the DB version match to app version. Since the deployment is done on the integration database automatically, if it is successful, the version file should be bumped up with app and DB compatible version. Assume you are asked to create a new fresh database and asked to deploy schema version of 10. How do you do it? This is how it looks like. Our project refresh or anything will create a vanilla database, and our downstream job deploy the version, like take that version, what version I have to deploy, and then it takes this all the scripts that are relevant to from the bit bucket and go to my database and start applying those scripts to the vanilla database. So then it takes the reference or sample data and apply to the database as well. So this is how all my automation scripts run, basically from a clean vanilla database, and apply the file-based scripts onto it. There are some native database tools also for source control and so structuring the data. Especially in the Oracle, we have 11G edition base for PLSQL procedures and packages, wherein we have one package called dbms_wm, which is a workspace manager since version 8i actually, for tables and its data. So these tools are native database, works inside the database itself. So it can take a version of your data, it can take a version of your tables. It also manages your PLSQL procedures within the database itself rather than having another source control. But none of the other databases does not have the native database tool capacity for source control your data and the structures. But when you are in a DevOps pipeline, we want to have a consistent process. For Oracle, this is one process. For the different databases, this is another process. Really does not suit for the DevOps environment. So as such, we covered like refactoring tools, like applying the database changes. What kind of tools? We have already explored one tool called Liquibase, and I'll show you how it works. Why Liquibase is basically, it's an open source database and it's an XML format. Whatever changes you want to do the database, you can write an XML piece of thing, and then it can be applied to any database. That's the beauty of XML. That means if you want to intend that script applied to Oracle, later on you move to Postgres, you can run that script on a Postgres database also. Liquibase automatically convert that create, alter, grant, whatever the statements compatible to that particular database technology. So what Liquibase can give you is basically the structural changes, data quality things, referential integrities, transformations, architectural stuff, and the custom scripts as well. So consistent database changes, manage database at different states like 1.4, 1.5, 1.6, something like that. Keep a history of changes in XML files, automatic rollbacks if there is any defects, ability of automation. You can automate it through your Ant, Maven, or within your DevOps tools, less human resources and errors. This is how your XML file looks like. If you see, there is a create table name, what are the column names, and this is one change set with a change log. So this change log is an XML file where now this can be applied to any database, not only the Oracle or something. So that's the beauty of your XML files are. So this is how you can call your Liquibase from a command line. Liquibase, what is the driver you want, Oracle driver or any other thing, and then host name, etc., your password, and run that script. Give that script name, generate change log. It actually refactor all your database from database changes. So if you want to update anything, you just say migrate. That means whatever there in this changelog.xml, it compares with the database and apply the changes that it is required. So when you want to run it from, put this all SQL files, XML files in a source control, you can keep that in a Git bucket. There is a Perl script called Liquibase Git, which can actually call a Git repo, my source control, and then log to my database, apply that change set.xml file automatically. So under beneath, liquibase.git actually calls Liquibase software and then do all your stuff. Only change that it is basically is it maintains the Git repository and do the things. So some of the good references are already have been in these blogs, Refactoring Database book and Martin Fowler for the evaluation of DB design, and some of the databases tools links already given here. You can go through with that. Thanks for joining. Any questions you have, please let me know. Okay, so you can reach me at this email ID as well. If you have any questions, please send me a note. I can reply to that. Thank you. Have a good day.